here we go. This is what's called the reciprocity law. Let me give you the definition of it first. Okay, the reciprocity law is any combination of MA and time. Any combination of any combination of MA and time that will give you the same mass. That's the reciprocity law.
Okay.
So let me give you some examples of it. So you're going to make 3 columns here, one for MA, and one for time, and then together mass. So here's our first technique, 200 MA at 1/10 of a second. Multiply those two together, and it will give you 20 mass. So the definition of the reciprocity law is any combination of MA and time that gives you the same mass. So what I'm going to do is manipulate my MA and time in such a way that I still have 20 mass, but a different combination of MA and time. Okay. So now I can have 400 MA at 0.05 seconds, still 20 mass. I can have 100 MA at 0.2 seconds, 20 mass, all 20 mass. So, why? Why do this?
The bigger the person. Density?
Well, wouldn't they all give you the same density?
Mm-hmm.
Wouldn't they? Because it's all 20 mass, so it's all the same density. What would be different?
Motion.
Motion would be different, wouldn't it? So, which of those techniques would you like to use for a small child?
200 by 0.1.
Yeah, you would want to use the one with the shortest exposure time, which would be this one right here. That's the one that you would want to use for, if you are concerned about motion on your film, use the reciprocity law to raise the MA and reduce your time. That's how you use the reciprocity law. If you're concerned about motion, double the MA, cut the time in half. You'll still end up with the same mass. Okay, so here's another question for you. Which one of those would give the patient the highest dose? Which one would give the highest dose? The longest time? Highest,
200
the
by-
highest MA? Because isn't that the quantity of x-rays? Yeah. And what if I was to tell you this? What if I said the dose is identical for all 3 of them?
Because it's 20.
Wouldn't it? Because the mass is still the same. The dose, and you should stick this in your notes, the dose is identical for all 3 of these exposures. Because if the dose was different, we would have a different density on our film, wouldn't we? We would. We would have a different, if we ended up with a different density in our film, then our mass had to have changed. And since the mass is the same on all 3 of those, the dose to the patient is identical. Because what you have here, this final combination right here tells us our beam intensity. Beam intensity is dose quantity. Okay, that final combination out there. I don't care how I get there, but that final calculation for mass gives us our beam intensity. Have I used beam intensity yet? Beam intensity is how you describe the dose. Beam intensity is quantity. Beam intensity is a quantity of x-rays. It's the dose. So mass controls beam intensity. Okay, now I have one caveat with this. What's the most, what part of that up there is the least accurate? The AMA is least accurate. This will only work if you've got calibrated equipment. If you don't have calibrated equipment, it's not going to work. The problem with the reciprocity law is you start changing MA stations. And you know that 400 MA station might work every time, but that 200 MA station might not. Okay, that's the only warning, is that you have to have equipment that's calibrated. Okay. But that's reciprocity law. So when you see reciprocity law, think motion. I want to get rid of motion. Go up in my MA and down in my time. Okay, 30% rule, still talking about mass now. It's an easy one. Okay, so we learned one formula called the reciprocity law, and that's a little formula. The next formula that we'll learn is called the 30% rule. 30% rule. And I don't have it defined, so I'm going to give you the definition. The 30% rule is as follows. It is the minimum amount of mass required to produce a minimum change in density. The minimum amount of mass required to produce the minimum change in density. It takes 30%. You have to change your mass by 30% in order to see it on the image. So, if I set 100 mass, and I see my film, I want my film a little bit darker, and I set 120 mass to compensate, am I going to see it? I'm not even going to see it. The human eye is not acute enough to tell the difference between 100 mass and 120 mass. To you, it would look identical. Okay? You have to go to at least 130 mass in order to have my film be a little bit darker. That's how you use it. So when you guys are working in lab class and you say, I want to go from 100 to 115, that'll make my film darker. Will it? It will on that densitometer. The densitometer can tell that difference, but our eyes can't. So you want to make your changes at least 30% in order to see a minimal visible increase in density. So how would you change the following technique if you wanted a minimal visible increase in image density by adjusting the mass? Okay, so I'll let you write that down, then I'll give you the technique. This is like a sample problem that you'll have in the quiz. I have a little worksheet I'm going to hand out that you guys tinker with in your spare time. And your spare time is probably waning right now, isn't it? This week, we're getting into the full swing of things, although we're off on Monday. How about that? Sounds pretty good. Hope it's nice weather.
We studied.
Okay, so there's our technique, 120 kVp and 50 mass. Do I need to know anything about kVp? No, that's a distractor. So the first thing you need to do is just pretend that's not there. Okay. So I want to go up 30%, and I'm going to give you all the steps. This is like the long version, and I'll show you the short version. I want to go up 30% in my mass. So basically I need to multiply 50 mass times 30% and then add that back again to 50. So it ends up being 65. 50 times 30%, 0.3 plus equals 15, and then plus 50 is 65. Okay, easy math. Okay, now there is a way to do this in one fell